By now, you have these basic ingredients in concrete down: fine aggregates, coarse aggregates, cement, and water. And we've looked at the value of replacing some of those cements with pozzolans, and we've discussed some of the things you can do with chemical admixtures to alter the properties of the concrete. But now let's go ahead and take a look at that water. So first things first, we do need to make sure that we're using the correct water, and this is usually pretty easy. We generally just need to make sure we're using potable water, or water that's safe to drink. And this is really just to make sure that the water doesn't contain any biological ingredients that are going to damage our concrete. Now, this does mean that if we're going to do something like draw water from a source like a lake, then we might need to filter that water before we use it to make concrete, or at least get it tested by somebody who's knowledgeable to make sure that that water doesn't contain anything that's going to be detrimental to our concrete. But other than that, what we really focus on when we talk about water and concrete is how much. So from a chemical standpoint, I really need very little water in a concrete mix to complete that hydration process that we've been talking about. Most of the water that we put in our concrete mix, we really put there to make the concrete more workable, make it easier to pump or easier to place and move around. And most of that water is not going to get used up in that hydration process. And that's where the problem lies. The water that gets used up during hydration, that is the water that combines with those cement particles and grows those fingers that we talked about that bind all the aggregates together, that's good water. So we need it for hydration, and it's going to be used up during that chemical process. It essentially goes away, so I'm not worried about it. It's the rest of that water, the water that we put there to make the concrete more workable, and that's really what we're going to call free water. And the problem with free water is that it can make concrete weaker and less durable, and that can happen in a couple of different ways. So one, some of that water is going to bleed out the top of the fresh concrete as it hardens. Too much bleed water is going to increase our finishing time, cost me more money. And too much bleed water can also cause the surface to be less durable. But not all that free water is going to bleed out the top. Some is going to stay absorbed in the concrete itself and make that concrete less dense. And that makes the hardened product weaker. So that's why concrete technicians and people that make the mix designs really concentrate on what we're going to call the water-cement ratio. Now, this is simply the ratio of the weight of the water to the weight of the cement. Now, ideally, on paper, this ratio would work out to 0.4. So in other words, when I divide the weight of the water by the weight of the cement, I want an answer of 0.4. And that's going to give me enough water for a complete hydration process, but not so much that I'm going to have a bunch of free water in the mix that'll never be used up during that chemical hydration process. Now, the problem here is that a mix that contains only enough water to have a water-cement ratio of 0.4 is really stiff. It's hard to move around, and I guarantee you the people placing the concrete in the field are going to complain that the mix is not plastic enough or flowable enough. It's too hard to work with. So many mix designs are going to contain more water than that to help with that workability issue in the field. The key here is that as the water-cement ratio increases, the final concrete strength always decreases. Put that in simpler terms, the more water I add to make the concrete easier to work with, the weaker the concrete becomes, period. And that's why you'll hear engineers and inspectors out in the field tell the people placing the concrete out there that they can't add more water to the mix once it gets on site. So that brings us to water-reducing admixtures and plasticizers to help us solve this problem. Now, these are chemicals, and again, I've used both liquids and powders, and they make the concrete flow better without adding water. So you can take and mix a batch of concrete at a really low water-cement ratio and see that it's stiff. You can then add a little bit of water-reducing admixture and see that it becomes more flowable. I can add a plasticizer, which is really just a higher range water-reducing admixture, and it becomes even more fluid. Now, depending on the application and the geographical location, it's really common these days for concrete used on virtually all construction projects to contain at least some quantity of a water-reducing admixture to, again, reduce the amount of water in that mix to a level where we're not impacting strength. Now, as the demands for flowability increase, it's becoming more common to see that water-reducing admixture stepped up to that higher range plasticizer type of admixture. Now, in this category of water-reducing admixtures and plasticizers, we're also now seeing a new category of admixture emerge that makes the concrete even more fluid than we've ever seen before, while requiring very little water. So stay with me, and we're going to take a look at what we're going to call self-consolidating concrete.